Hey there, welcome to this exciting session where we are going to delve more into Kubernetes and we are going to deploy some of our services like Zipkin, RabbitMQ over there. So if you are new to this particular channel or if you're watching my videos for the very first time, I would highly recommend that you check out the earlier videos in this particular series because this video is a part of an entire series. And watching the previous videos will help you get some context into the source code that we are using. So you will find the link to the entire series in the description of this video. Talking about what we are going to cover. So we are going to learn how we can deploy things like RabbitMQ, Zipkin, and PostgreSQL to Kubernetes. So this particular video will have a step-by-step guide on how you can do the same. So this is going to be a complete hands-on session where we will be actually doing things in a hands-on way practically. Now, if you have been watching my videos and if you haven't liked or subscribed yet, I would highly recommend doing so because every subscriber or every subscription that I get on my channel motivates me to bring in more such amazing content for you all. The support and love that I get from my viewers impacts my ability to bring in more such amazing free content for you all. So I would highly recommend that you hit the subscribe button, like this particular video and turn on the bell notifications. Also feel free to leave a comment to let me know what kind of videos I should bring for you all. Now without a further ado, let's jump right into the session. Hey there, welcome back. So let us begin deploying Zipkin, RabbitMQ, Postgres to Kubernetes. And for that, we will first define the folder structure or the project structure over here. So here I have some files, but I will be creating a new folder over here. Okay, so I'll say one folder can be Bootstrap and I'll have one more folder. Okay, so this folder won't be under this one, but it would be in the main directory. So I'll say services. Okay, so these are the two folders that will have everything that we need for deployment. Okay, now within the services folder, I'm going to have a folder for defining the configuration and the deployment for Zipkin. Then I'm going to have one for RabbitMQ, and then okay, so they all are being listed under Zipkin. So I'll just drag this to under services. Okay, so we have under services, we have two folders now. And I can add one more folder over here. Okay, so one is for Zipkin, one is for RabbitMQ, and then we have one more service, Postgres. Okay, so I'll add one for Postgres here. So this is where we have services. Now under Bootstrap, we can have all our microservices. Okay, so you can have company. Okay, and then under Bootstrap, you can add one more folder. You can call this review. And then under Bootstrap, you can add one more folder. And you can call this as job, like so. Okay, so you have multiple folders like company, job, review. And then you have services. Okay, so it's good to organize things this way, okay, because organizing things helps you find important things and also helps you with easier deployment. For example, if you want to deploy all your services, like not your microservices, but all these services like Postgres, RabbitMQ, and Zipkin, so you can just run a simple command kubectl apply -f and you can say k8s /services. So this particular command will take everything like all the files under all the subfolders as well under services and it will deploy them. Okay, and to deploy the microservices, company, job, and review, you can run the same command, but instead of /services, you can say /bootstrap. So this can help you with different aspects like organization, maintainability, and also add modularity to your structure. So this is a structure that we are going to follow. Okay, and what you can do is if you don't want, you can just move these files. So I'll just create one more folder. I'll say first, and under first I'll move all the files that I have over here. Okay, so that will just make things look a bit cleaner over here. Okay, so this is the structure that we are going to follow and we are going to build on. Okay, so yeah, I would recommend you all to create these folders and then we can get started with the next step. Hey there, welcome back. So let us start defining the configuration that we need for Zipkin to be deployed into Kubernetes. So we are going to need a couple of files over here. Okay, so here under Zipkin folder, I'm going to create a new file. I'm going to call this as Zipkin service.yaml, and I'll add one more file over here. Okay, I'll say Zipkin deployment. So this is the deployment file that I need. Okay, so why do we need deployment and service file? So deployment will be responsible for maintaining a specific number of replica pods running in the cluster, and service will be responsible for providing the network access to one or more pods. Okay, so I have the configuration ready with me, and the configuration is here in this notepad. Okay, so you can see here I have this is the deployment, and let me move this to the respective files. Okay, so I'll copy the deployment first, I'll paste it over here, and I'll hit save, and then I'll move the service part as well. Okay, and I'll copy this and I'll paste it over here. So let us understand what is happening now. Okay, so let's talk about deployment first. So here we are specifying the API version, the object kind, and then we are specifying the metadata. So this is the name of the deployment here, Zipkin. And then we are telling Zipkin, or then we are specifying that we need only one replica, and that is what this deployment tells. And then we have the selector defined. Okay, so we say app Zipkin, and this selects the pod with the label app::Zipkin to manage. Okay, and then you have the template over here, and this template also has labels of app::Zipkin over here. Okay, so this defines the labels to apply to pods created by this deployment. All right, and then spec defines the container definition. Okay, so you have container with the name Zipkin, and here is the image that you are using, and then here is the container port that you are exposing. So what you're saying is, you're saying I want to expose 9411 within this particular container, and this is a standard port for Zipkin's HTTP collector interface. So that is what we are defining and creating in this deployment file. Now in the service, what we are doing is we are exposing or providing network access to one or more pods. Okay, so here we have this general tags that we have mentioned, or general properties, and then over here we are specifying the port under the spec. Now port uses TCP protocol is what we have mentioned over here, and target port is 9411. So this defines the port configuration for this particular service, and it maps the port 9411 on the service to port 9411 on the target port. Okay, or on the target pods, not port, sorry. So this is what it does, and then you have the type of the service defined here, and the type you are creating is load balancer. Now a load balancer service will provision an external load balancer that can route traffic to the pods selected by the service. All right, so I hope this makes sense. So I'll hit save, and we will save this configuration for Zipkin. So together these configuration will deploy a single replica of Zipkin running in container. So this container name is also Zipkin, and this container will expose the port 9411. And we also have a service named Zipkin that routes the external traffic to the Zipkin container through a load balancer. So I hope this is making sense as to how service and deployment both will work together to bring Zipkin to life from within the Kubernetes cluster. So this is about Zipkin and the configuration that we need for Zipkin. Welcome back. So let us start talking about the configuration that we need to define for RabbitMQ. So here I'm going to create a couple of files. So I'm going to say RabbitMQ -service.yaml. Okay. And I will duplicate this particular file and I'll paste it over here in the same folder, and I'll refactor it and I'll rename it to deployment. Okay. Like so. So I have defined two files, or I've created two files for deployment and service of RabbitMQ. So I have the definition ready for the deployment as well as the service. So I'm just going to copy this entire file and I'm going to head over to deployment and paste it. So this bottom part is of service. So I'll cut this over here and I'll move this to service.yaml over here. Okay. And I'll save both the files. So just don't forget to save. Okay. So we are creating two files here, a deployment that will manage the desired state of our application. And it has all the definitions that are needed for the deployment to be created. And we have specified the replica over here as 1. Okay. So this will make sure that there is only one replica for RabbitMQ up and running at any given point of time. So this deployment file is necessary for this very reason, where it helps you to manage the number of replicas, the updates, and even self-healing. So let's say if I have defined one replica over here, and if this one replica fails, then the deployment will make sure that there is one more instance that is created for RabbitMQ and the service is not down. Okay. And we have specified the container over here, like the container definition, wherein we have said the container name is RabbitMQ and image is this image, and we are exposing a couple of ports over here. Okay. And we have specified the app label over here as well. So this is about deployment. And then we have service file, and service file, like we know, it enables us to get a stable IP, since pod can be deleted and created anytime. So IP keeps on changing for the pod. So service file helps us with a stable IP, and it's also helping us with the load balancing. Okay. And it also enables us to access this particular service from outside. So that is why we are creating this service file, and this particular file is enabling us to define the service for RabbitMQ. So this is about the RabbitMQ service and deployment. Welcome back. So let us get started by defining the configurations for PostgreSQL. So handling of PostgreSQL will be slightly different as compared to the other services, RabbitMQ and Zipkin, that we have over here. And there is a reason for this, because we want the data in Postgres to persist, and also there are some connection details and little bit of configuration that we have with PostgreSQL. So how do you manage this? So when deploying a PostgreSQL database on Kubernetes, it makes sense to use a config map, stateful set, volume, and a service. So these are the four things that we are going to need. Okay. Now, what is a config map? So config map is used to store configuration data in key value pairs. So let me show you the configuration. So I have this notepad here wherein I have the definition for all the four file types. So you can see this is config map. And here I have the definition of configuration, or the configuration settings, in the form of key value pairs. And this can include things like connection strings, memory strings, and other things as well that can be used for PostgreSQL tuning. Now we are creating a separate file to maintain the configuration. And the reason for this is it helps in separating the configuration from the image and the deployment, and allows for a bit of natural adjustment if we want to in future. Okay, so that is why we are creating a separate file over here. And also this can be reusable. So this is another reason why you should have a separate configuration file. So you can reuse this with different environments and instances. Okay, so this is about config map. So we are just storing configuration in config map. Now the next thing we have is service over here. So service, like we know, it is used to provide a stable endpoint for the applications to connect to PostgreSQL. Okay, so that is what we are doing over here. And then we have a stateful set over here. Now, what is a stateful set? So stateful set is used to manage stateful applications because databases require persistent storage and specific network identity, right? Because pods can be started and killed. So you need to have a mechanism for data to persist, and that is where stateful set come into picture. But the next file we have is the volume file, and this volume file represents a storage location. And for a database like PostgreSQL, where persistence is crucial, we need a volume file. Okay, now this is needed because we need data persistence. Now, when a pod dies, the data in its storage can be lost. And using a volume like persistent volume or persistent volume claim, like we have defined over here, it can ensure that the data remains intact. So this is one reason why we have used, and also performance. So you can choose different types of storage backends based on your performance requirements here. Okay, but persisting data is the main reason why we are adding a volume. So let us move all of this to Visual Studio Code. So I'll just copy all of this and I'll create a file over here. Okay, so let me create a file called config map. So I'll say config map.yaml. And I'll paste everything. Now let us move everything to their respective files. So I'll create one more file called service.yaml, and I'll create one more file called stateful set. Okay, so stateful set.yaml here, and I'll have one more file created here. Okay, and I'll call this file as volume.yaml. Now let us move the code in their respective files. Okay, so here after config map, I'll copy everything. Okay, and the next part that we have after config map is service. So I'll head over to service. I'll save this and I'll head over to service here, and I'll move this to service. So this is the service definition here. Okay, so if you scroll up, this is the definition of service. Okay, so I'll just select all of this till the end. Okay, and then we will head over to stateful set. Okay, here, and here at the top I have the definition for stateful set. So I'll press backspace and I'll copy the volume definition to the volume file. Okay, so I'll move this to volume file here, like so. So we have all the definitions set. Okay, now let us understand what each thing means. So we'll start with config map. Now here in config map, we are actually specifying the API version, the kind of the object, the name of the metadata, and here we are specifying few configurations, as you can see. So these are key value pairs that represent the configuration data. So we are seeing the database name is EmbarkX over here. And then we are saying the database user is EmbarkX again. And then we have the password as EmbarkX. Okay, so these are three configurations that we have added. Okay, then we have the service file. So service defines how to access the pods. Okay, and here we are specifying like the metadata, the kind and API version, the selector, the ports, and the type, which is cluster IP. So service type says it's of type cluster IP, and cluster IP makes it reachable only within the cluster. All right. Then we have stateful set. So stateful set will manage the deployment of a set of a pod and guarantee the ordering and uniqueness. So here in the beginning, we have standard things like API version, kind, metadata, and so on. And then we have defined the spec over here. Okay. So we have specified the service name as Postgres, the replica as 1, and we have the selector which matches the label of Postgres over here. Okay. So what it will do is it will select the pods with label app:postgres. All right. And now under template, we have defined the template for creating the pods. So we have the metadata wherein we are specifying the labels over here. And then we have the specification of the containers. Okay. So this defines the configuration for the container named Postgres over here. Image we are using is of the PostgreSQL. So this is the official image that we are getting. And we are specifying the image pull policy over here. Then we have env from. So this is going to import the configuration and environmental variables from the config map named Postgres config. Okay, so if you go over here, you have this config map called Postgres config. So this is going to be imported over here. Okay, and then we are defining the resources over here. Okay, so we are saying requests. Under requests, we have CPU 100M and memory of 256, and limits, we have specified some limits over here. Okay, so these are like different configurations of the memory and CPU capacity that you wish to have. Okay, and then you have volume mounts over here. So this defines where the volume will be mounted in the container. Okay, so we have specified the name and the path of the volume mount. Now if you scroll down, we have volume claim templates. So this is a template for creating persistent volume claims. Now, what does persistent volume claim mean? So persistent volume claim requests a specific amount of storage that can be used by a particular pod. So we are saying access modes as read write once. Okay, this is the access mode that we are specifying, and we are specifying the storage wherein we need 5 gigs of storage. Okay, so this is the definition of the stateful set. And then we have volume.yaml. Okay, wherein we have created a volume of persistent volume claim. All right, and we have named it as Postgres PC volume claim, and the label of the app is Postgres over here. And then within spec, we have defined the storage class name as manual, and this specifies the storage class name to use. And then we have the access mode and the resources again specified over here. So this is the configuration that we need to do for PostgreSQL, and these configurations together set up a single replica PostgreSQL database within the Kubernetes cluster. And they include the configurations for environmental variables, how to access the pods, and how to manage the deployment, and how to handle storage, ensuring that the data persists even if the pods are restarted. So that is really important. So this is about the configuration for PostgreSQL. Hey there, welcome back. So now we have the configuration set for all our services, and now it's time to run them. So what I'm going to do is I'm going to delete first whatever I'm already running. So if you see over here, and if I run get pods, you will see there are quite a few pods that I'm running already, and there are quite a few deployments as well, like so. So instead of getting deployment pods and services individually, I can say kubectl get all, and you will see that it gives me a list of everything like replica set, deployment, service, and then pods as well. Okay, so what we need to do is we need to start deleting all of them, and then we need to start deploying our services. So this is something we created for learning purpose. So we will delete all of this. So I'll start by deleting deployments. Now I'll say kubectl delete deployments -2 times all again, and then I'll say namespaces like so. Okay, so this will delete all the deployments. Now I need to delete all these services. So I'll just run the same command, but I'll replace this with services. Okay, and then I'll run the pods over here like so. So you can see now everything is deleted. Okay, and you can like run kubectl get all. You can see few replica sets still exist. Okay, so you can even delete them. So I can say replica sets. Okay, and if you say get all, you will see like nothing exists now. Okay, so we have cleaned everything. It's important that you go in order essentially. So you delete the deployments first, services first, and then you have pods. So if you're deleting deployments first, deleting deployments will cause the associated replica sets and pods to be deleted as well, because you're deleting the higher level entity. And then if you delete the services after deployments, this ensures that you don't have services attempting to route traffic to non-existent pods. And then you finally delete the pods which are not managed by any deployments out there. Okay, and you need to be careful about the delete commands. Okay, because we are running them across all namespaces, so everything is deleted here. So now since we have deleted everything that was running, now it's time to run our services. So we are going to start with PostgreSQL. So right now I am in k8s directory, and I'm going to say kubectl, and I'm going to say apply -f, and let me say services, and I'm going to go to Postgres, and I'm going to run deployments. Okay, so for Postgres, we do not have deployments.yaml. So you just have to go to the directory here, and you just have to press enter. So it will pick up all the files, and it will get everything created. Okay, so now if you say kubectl.getAll, so you will see like everything for Postgres is up and running. So you have a pod, you have a service, and you have a stateful set as well. All right. So this is how we can get PostgreSQL up and running. Zipkin and RabbitMQ is something we will touch upon later, but for now, let's get started with PostgreSQL. Hey there, welcome back. So we now have PostgreSQL running in Kubernetes. Now what we need to do is we need to log into Postgres, and we need to create the databases. So remember, our microservices need 3 databases: job, company, and review. So we need to set that up. So what I'm going to do is I have everything up and running. You can see over here, I have the pod, the service, and the stateful set up. Now what I can do is I will say clear. I'll say kubectl, and I'll run this command. I'll say -it postgres -0, and I'll say -2 times psql_u embarkx. So let me explain what this command means. So here, this command is used to log into the terminal of PostgreSQL. So we are saying kubectl execute exec, and this is a command that is used to execute a command in a already running container within Kubernetes cluster. All right. Then we are saying it. So these two flags, I and T, stands for interactive, and T stands for TTY, which stands for terminal. So together they allow you to interact with command you are running inside the container as you were connected to the terminal session in that container. All right. Then we are saying Postgres -0, and this is the name of the specific pod that the command will be executed in. Then we have hyphen 2 times, and this symbol signifies the end of the command line options for kubectl exec. So this was the command line option for kubectl exec, and we specify that it's end of the command line options and the beginning of the command you want to run inside the container. So now inside the container, we are running this command. So we are saying PSQL -u embark x. So this command gets run inside the container. PSQL is the command line client for interacting with the PostgreSQL database, and -u embark x part specifies that you want to connect to user embark x. So let us press enter and let us see what's happening. Okay, so it says Postgres-0 does not have a host assigned. So I'm getting this issue. Now what I'm going to do is, I don't know why this issue is coming in. So I will be restarting Minikube. This could be one of issue with Minikube. So I'll say Minikube stop, and this will power off Minikube, and I'll say Minikube start. So I'll say Minikube start over here. Okay. So it will restart Minikube for us, and then I'm going to redeploy or rerun PostgreSQL, and then I'm going to try this command again. So the restart is complete. You can see the logs over here. Now what I'm going to do is I will apply. So let me say apply services Postgres, and you will see everything is created now. Okay. And now I will, let's say, I'll execute this same command here. And now you will see that we are logged in to the terminal of our container. All right. Now we need to start running some commands here, and we need to get our databases up and running. So what we can do is we need to first check the list of databases. So I'll say hyphen and I'll say L. Now here you will see these are nothing but the databases over here. So you can say /L or /n list. So if you say, so here you have more list, okay, and you end over here. Okay, so the command is done, and you can see we got 4 records here. So either you run -L, sorry, not hyphen, or /L, or you can say list over here. Okay, and you will see the same thing. So you have this database, or you can see like you have this database created here, embark x, which exists already. Okay, so I'm just going to press enter, and we will exit this. Okay, so I said Control C on Windows, and then I pressed enter for the output to exit. Okay, or you can press Command C if you are on Mac. All right, now what I'm going to do is I'm going to create the database. So I'm going to say create database job, and I'll end this with semicolon. Then I'll create a database called review. It will create the database, and then I'll create a database called company, and it will create the database. Now if I run list, you will see we have all the databases up and running. Okay, you can see there are 7 rows now. So we have company, job, Postgres, and review. So company, job, and review is what we will be using. So now to exit this, I'll say Control C and I'll press enter. Okay, so we have now successfully created the databases within the container, and now we need to exit this shell. Okay, we don't need to stay in this shell now because we have database that we have created. So I can say Control D on Windows to quit the shell, and if you're on Mac, you can say Command D. All right, so this will quit the shell and you are back to the normal PowerShell. So if I say pwd, you will see that I am in my normal directory now. So that's about PostgreSQL and how you can set it up within the containers.